the security industry also would agree with this as a laudable goal. I'm sure many in this room also share this with their respective roles. My job on the team has been to break the feature in any way possible that I can, so that the architects, the implementers, the designers, the whole team can produce a better secure product in the end. This is the first publication of this presentation outside of Microsoft. I've been giving it within Microsoft for about a year now in various versions. This is the first time in the world that Microsoft is publicizing this information. And I'm sure that many in the audience, especially when the slides hit the internet, will be very surprised at the candid nature of the discussion of these threats. But I think the transparency is really important. So it's important for three reasons to me. First off, the threats discussed within this presentation are not secrets. They may be secrets to some of our customers. They may be secrets to some of the professionals in the security industry. I'm sure that some of you sitting here will know about some of these threats against the platform in general. But I know one thing for sure, that our adversaries of the customers are well aware of these attack vectors. So this makes my third point very important, is that I feel, Microsoft feels, that our customers also have to understand these threats so they can make the right decisions about the configuration of the product and how they use it so that it meets their data protection needs. The presentation outline is like this. I'll give a very brief introduction to the feature. This isn't a marketing presentation. I'm not here to sell you a new feature. I'm here to discuss the threats and the configuration options available to it. So that will be very brief, just so that you understand enough that the threats are meaningful to you. Even if you're not interested in BitLocker or Vista in general, I think you'll find many of the threats against the platform interesting. I mean, a lot of the threats you'll see have to do with the device itself and not necessarily the OS. I'll also go into very focused technical highlights, just so, again, that you understand the threats a little bit more in the context. I'll discuss very briefly some of the pen testing process. I removed most of this from my presentation because yesterday my colleagues talked a lot about that. So today, especially given the time that we have, it's the core of the talk is going to be focused on the top threats, which I think most of you will find more interesting. I split the threats into two sections. The first section is in the feature in its basic mode. This is the mode I think that most customers will be using. The second section of threats are in BitLocker in its advanced modes. So at its core, BitLocker drive encryption is all about data confidentiality. It encrypts the entire OS volume. So not just a folder or file or even a loadable image. It's the entire OS volume. The page file, the hibernation file, temp files, free space, the registry, everything, the kernel, applications, and user data. Just everything on the volume is encrypted. The byproduct of encrypting the entire OS volume is that you get secure decommissioning for free. Well, not actually for free, but it's very easy to decommission a hard disk because you simply throw away the keys to the hard disk and the data is inaccessible. The second core element of BitLocker is the system integrity element. And this is very new for platforms and OSs in general. We cryptographically validate the entire pre-OS load elements. So I'll go into this more deeply in a moment. The core threat model that we use, the threat scenario that we use, is a lost or stolen laptop. This is where you leave it in the back of a taxi or get stolen from your hotel room or something akin to this. It's not the only threat model that we use, but this is our primary one. And BitLocker also comes with multiple levels of protection through its basic and advanced modes. I always like to come back to this slide because as a penetration engineer, as a paranoid person, I always like to focus on the security elements of a product. But when you consider security management in general, you always have to remember the three elements of a whole solution. That also, along with security, it also has factored into it the usability of the product and also its affordability. This is a slide captured from Jesper Johannesson. And IT management and security management in general is all about balancing that and finding that central little point that balances those two factors. There's 3 points I'd like to, I hope that you remember from this presentation. The first one is that BitLocker in its basic mode provides a higher level of protection with no additional security burden. I'll get into why this is so significant as we move through the presentation. But the point here is that you see, as I discussed the feature level, is that an enterprise can turn on disk encryption across its domain, and the end users are not going to have to do anything different. There's not going to be a dongle to be used. There's not going to be an additional PIN or password in this basic mode. This is significant because a lot of times very good security products simply aren't used because the end user cost is too high. The second point that I hope you take away from this is that as you'll see, there's a range of configuration options. There's the basic mode, which gives you a really high level of ease of use. But there's also advanced modes that mitigate some of the threats against the basic mode. And the third point is that BitLocker has significant security dependencies on the hardware device itself, so you need to make sure that if you deploy BitLocker, that you're doing it on platforms that meet the Windows logo requirements. One of the key elements of BitLocker is its use of a trusted platform module. You can think of this as a chip that's very similar to a smart card. If you understand the security attributes of a smart card, then you understand a TPM for the most part. I think my audio just went out. Can you add my audio? Because I don't think I can shout that loud. Can you hear me again? Yes. The other thing about the trusted platform module is that it's fastened onto the motherboard. So it's not something that you plug into the machine to the USB port. It's not something that you put into as a PC card or anything like that. It's fastened onto the motherboard, soldered onto the backplate. It uses platform configuration registers, and I'll get into what these are in a moment. TPMs can have temper resistance, temper reaction, and temper evidence features. There are many OEMs that produce TPMs. Some of these have a long history in smart cards. So you'll see some of the same attributes, like for instance, a TPM vendor may implement self-destruction, for instance, under some circumstances. All of this is, the TPM is all designed and spec'd out under the Trusted Computing Group's specification, and this is all available on the World Wide Web. You also can use BitLocker without a TPM. You can use it with a dongle. But again, this now it requires you to carry something around and keep separate from your hard disk. Its basic mode uses only the TPM. As I said earlier, there's no additional PIN, password, dongle to carry around. It just uses the TPM and its cryptographic validation of the pre-OS components. The advanced modes are a PIN, so it combines the TPM capabilities along with the PIN capabilities, a USB dongle, and as I mentioned just a moment ago, just the USB dongle with TPM. One of the conceptual elements that we build within BitLocker is what we call a trusted computing base. And this is something that we didn't come up with. This is a standard within the industry. And here's the InfoSec glossary definition of what it is. But how BitLocker uses this is to develop a trusted identification of all the code and data that's loaded during boot. With this trusted computing base, it allows the OS to have a foundation that we can build upon. So OS code integrity can be built upon this, and then, for example, 64-bit platforms, digital signatures for kernel mode software. So let's go through what a trusted computing base validation is all about. Here you see the PC elements that comprise the pre-OS environment. Here we have the BIOS, the MBR, the master boot record. boot sector on the booting partition and the boot manager. Now, for Vista, NT loader has been divided up into two pieces, the boot manager and then WinLoad. If you ever have multiple OSs that are on one system and you get to a menu in Vista, you're running boot manager. So that's where you are now. So the first thing that happens on the system when it is started is that control is passed to the BIOS. The BIOS then takes some measurements from its core root pressure measurement, and I'll talk about this in a moment, and puts it into one of the PCRs. Here are the PCRs here. TVMs can have more than 4, but just for this presentation, the example just has 4. But there are many, depending upon OEM's specification. That's the first thing that happens. The next thing that happens is the BIOS takes a measurement of the next component in the pre-OS chain, puts it into a PCR, and then passes control to the next component. This is repeated across the pre-OS boot chain. As you see, the next step is, again, the MBR is going to take a measurement of the boot sector, put it into a PCR, pass control to it. The boot sector takes the measurement of the boot manager, puts it into PCR, and passes control to it. At this point, everything that's run and all the data that's been consumed has been measured and ends up as a hash into one of these PCRs. These PCRs can be thought of as a one-rate hash register. On system init, they all are 0. Each successive extension of the hash into a PCR, the TPM will take the current value, the input hash that's given to the instruction, and hash it into the PCR. So you can think of these PCR registers as only one way across a system init cycle. At this point, the boot manager is going to attempt to unlock the OS volume. See the OS volume here. Oops. No, you got it. The OS volume is on the right there. It's locked. And the boot manager is going to attempt to unlock it. The first thing it does is it locates the encrypted key data on the OS volume. He passes it to the TPM. The TPM is going to check all the PCR measurements to see if they match the values at the time BitLocker was turned on. And if they do, it's going to pass the key back to the boot manager and unlock the OS volume. Would you like to see that again? Okay, let's do that once. So the BIOS has control. The system has been booted. The first measurement gets into the PCR. It takes the measurement of the next component of the pre-OS environment, puts it in the PCR, passes control to it. It does the same thing in the chain. Passes control of the boot sector. Boot sector takes measurement of the boot manager. At this point, the boot manager is going to try to unlock the OS volume that's booting. It passes this encrypted blob into the TPM. The TPM is only going to release this key if the PCRs match what they should be. In this case, they do match. It passes the key back, and the OS is unlocked. At this point, we can pass control, the boot manager can pass control to WinLoad, which is going to load the kernel, etc. Before we start talking about the threats against the TPM-only mode, again, the basic mode, let's think about what the adversary's objectives are. Obviously, the ultimate objective is going to be reading the plain text of the data off of this. Plain text is a cryptographic word for the original unencrypted data. And the intermediate goal would be to gain access to the encryption keys, right? And then if they have access to the encryption keys, then they can get the plain text data off of this. Another intermediate goal would be to gain control of some privileged thread, especially within the trusted computing bits, right?